You know, we spend our whole day clicking, tapping, and swiping. We tell our apps to do stuff, and they just do it. But have you ever really stopped and wondered how that works? I mean, how does a simple human tap get turned into a precise command that a machine can follow perfectly? Well, that's what we're going to dig into, the secret journey from your click to the computer's command. It really does feel like magic, doesn't it? You click Buy Now, a package shows up. You tap play, music starts. But you and I know it's not really magic. It's a super carefully designed process. This is all about pulling back the curtain and seeing how we take a kind of vague human idea and turn it into instructions so specific, so precise that a computer literally can't get it wrong. And believe it or not, the very first step is just storytelling. Yeah, way before anyone even thinks about writing code, analysts and designers write up these little stories called use cases. A use case is just a simple, step-by-step story of what you, the user, are trying to do. Like, for buying a plane ticket, it might just start with, Step 1, the user tells the system they want to buy a ticket. It's all about capturing the goal in plain, simple English. Okay, so visualizing the conversation, once we have that story written down, what's next? Well, now we have to actually draw it out. We need to create a kind of visual map of the back and forth conversation between you and the system. Think of it almost like a little comic strip for just one task. And this map, it's got a proper name, a System Sequence Diagram, or SSD for short. The most important word there is sequence. An SSD doesn't care about all the complicated stuff happening inside the system. Nope. It just shows the messages, the events that go back and forth between the actor, that's you, and the system itself. So the whole setup is beautifully simple. You've got the actor, you, on one side, making a request. Maybe something like, enter item. And then you have the system on the other side. The arrows just show the flow of that conversation. It's this really clean, high-level picture of who says what and in what order. All right, next up, defining the rules of the game. So here's the thing. Just having a map of the conversation, it's not quite enough. For every single one of those requests you make, the system needs to have a rock-solid, crystal-clear rulebook. It has to know exactly what needs to be true before it can do something and how things will change after it's done. And this rulebook is called an operation contract. And honestly, this is the secret sauce to making software that works reliably. A contract has two absolutely critical parts. You've got preconditions. Those are the rules that have to be met before the operation is even allowed to run. And then you have postconditions, which describe exactly what's different in the system after the operation is over. So let's just break this down real quick. You've got the operation name. That's the specific action, like make new sale. The cross-references just tie it back to the story, that use case we talked about. The preconditions are like the entry requirements. You must be this tall to ride. And the postconditions, well, that's the promise. That's the guarantee of what will be different after the operation is complete. Altogether, this leaves zero room for guessing. Okay, so we have our visual map, the SSD, and we have our rulebook, the operation contract. Let's put this all together and see how it works. The blueprint in action, using a super common example, the process sale at a checkout counter. So here's our story, the use case. It's so simple, right? You've seen this a million times. The cashier starts a sale, scans items, and the system keeps a running total. This simple, everyday narrative is the foundation for everything technical that comes next. Now watch this. That very first simple step from our story, cashier starts a new sale, that gets mapped directly to a specific system operation called make new sale function. See that? We've translated plain English into a command the system can understand. But what does that command actually do? Well, for that, we have to look at its contract. And here it is, the rulebook for make new sale call. First, notice the preconditions. None. That makes sense, right? A cashier should be able to start a new sale anytime. But look at the post conditions. They are super specific. After this operation runs, we are guaranteed that 3 things have happened. A new digital sale has been created. That sale is now linked to a specific cash register, and all its basic details are set up. The system's internal world has officially changed, precisely as planned. So you might be thinking, okay, that's a lot of work. Diagrams, contracts, why bother? Why does this blueprint matter so much? This is where it all clicks into place. See, for us as users, a system is basically a black box. We put a request in, like a click, and we get a result out. We don't really know or care what happens inside. But for the people who have to build the software, it has to be a white box. They need to see every single internal part. And these tools, the use cases, the SSDs, the operation contracts, that's what cracks open the black box and makes everything inside visible and understandable. So what's the bottom line here? It all comes down to creating one thing, an unambiguous blueprint. When a developer gets a contract like the one we saw for Make New Sale, there is no confusion. There's no guesswork about what they need to build. This prevents so many bugs and ensures the entire team is working from the exact same plan. So, the next time you tap a button on your phone, just remember what's happening under the surface. You're not just clicking, you're kicking off a system operation that's governed by a super precise contract, a contract that was born from a simple little story. It really makes you wonder, doesn't it? What other hidden blueprints are out there, quietly shaping our digital world?